Welcome to week 4 of distance learning. It's Mrs. Lewis. I'm so glad to have you with me today. Let's get started right away. Ever wonder what your chances are of winning the lottery? Determining the chance of an event happening is called probability. Probability is usually written as a fraction, decimal, or a percent. There are different types of probability. First, we'll go over simple probability. Once we have an understanding about simple probability, we will then go over compound probability. Simple probability is simple. With simple probability, we want to find the chance of one single event occurring. When learning probability, we often use real items like coins, dice, spinners, marbles, tiles, or even playing cards. Let's take a coin, for example. How many possible outcomes are there to flipping a coin? Hopefully you said 2, heads, or tails. When you write probability as a fraction, you want to put the number of occurrences of the favorable event, or the event you would like, as the numerator, and the total amount of outcomes as the denominator. So if you were asked, what is the probability of flipping tails on a penny, you'd have to ask yourself 2 questions. First, how many times does tails occur on a penny? Or how many tails are there on a penny? The answer is 1. Tails only occur 1 time on a penny. So 1 will be your numerator. Second, how many total outcomes are there? The answer is 2. If you flip a coin, there are only 2 outcomes, heads or tails. So your denominator will be 2. Once you've written your fraction, you know that the probability of flipping tails on a penny is 1 out of 2. We can divide the numerator by the denominator to come up with the decimal, and then convert that to percent. What percent is 1/2 equal to? 50%. And how would we write that as a decimal? 5/10. Looking at this continuum, we can find the likelihood of flipping a tail when we flip a coin. Since the probability was 1/2 or 50%, we can say there's an equal likely chance to flip a head or a tail on a coin. Let's try another example. Example 2 is about rolling a dice. What is the probability of rolling a 4 or a 5 on a dice in one roll? Let's review first. What will be our numerator? Our numerator is where we'll put our favorable outcomes. What will we make for our denominator? Yes, we need to do the number of possible outcomes. Looking at if I roll a dice 1 time, how many favorable outcomes am I going to end up with if I'm wanting to know the possibility of rolling a 4 or a 5? Yep, 2. How many total possible outcomes do we have when rolling a dice? 6. Now, we can simplify that fraction. What would 2/6 simplify to be? Simplifies if we divide both the numerator and denominator by 2. It will simplify to 1/3. How might we write that as a percent? Yep, 33%. Let's try another one. This time we have a spinner. We want to find the probability of spinning blue. Again, what goes on the top? Yep, the number of favorable outcomes. And what goes on the bottom? Yep, our possible outcomes. What's the probability of spinning a blue? How many favorable outcomes do we have? And what is our total possible outcomes? Yes, so the probability of spinning a blue is 1 in 4. How might we write that as a percent? If you can't remember, think in terms as 1/4 of a dollar. Yep, it's 25%. Now let's do some extra practice. We're going to calculate the probability of each of these independent events. So the first one is we want to find the probability of the spinner when we spin it one time landing on a red space. So we're going to look at the spinner on the right and write the fraction representing the probability of landing on a red space. Whenever possible, be sure to simplify your fractions. For number 2, we are going to write the probability of landing in a blue space. Again, don't forget to simplify if you can. On the third one, we're now going to look at the numbers on the spinner, and we want to write the probability of landing in a space with an odd number. Finally, number 4, we want to write the probability of landing in a space that is yellow. So we should have gotten the following. The probability of landing in a red space was 3 out of 8. Blue was 2 out of 8, which we could simplify to 1 out of 4. Odd numbers, there are 4 odd numbers, 3, 1, 3, 5, and 7. So that would be 4 out of 8, simplifying to 1/2. And the probability of landing on a yellow space was 1 out of 8. Compound probability is similar to simple probability. Compound probability is actually a combination of 2 or more simple events. Our focus on compound probability will be finding outcomes using tree diagrams, or we can also make a list. Flipping a coin is a simple event. But if we flip a coin more than once, we now have a compound event. What are the possible outcomes of flipping a coin twice? First, we know that we will have heads or tails. Now, we are going to draw this tree diagram, and it would be very difficult to draw those coins, so we can just put an H or a T. Unless you're super artistic, go for it. So our first flip has 2 options. Our second flip also has 2 options. What are they? We have the option of flipping a head or a tail. A head or a tail. So we have 4 outcomes altogether. We got a head first for our first flip and a head on our second flip. We had a head on our first flip and a tail on our second flip. On our third flip, we had a tail and a head. What will be our last outcome? Yep, it will be a tail and a tail. So we have 4 outcomes all together. Now, let's extend our learning to a more complex example. We are going to help Mrs. Lewis figure out how many different dessert setups she can make with what she has in her kitchen. So we're going to find what we're looking at. What we're going to try to find is the total number of different dessert setups that we can make with the following choices. We have 2 containers. We have a regular cone and we have a waffle cone. Besides our 2 containers, we have 3 flavors of ice cream: chocolate, strawberry, and cotton candy. We also have 3 toppings: chocolate crumbles, sprinkles, and a candy shell. How many different combinations exist if we can only have 1 container, 1 scoop of ice cream, and 1 topping? We're ready to construct a tree diagram to explore how many different combinations exist. So let's draw the tree diagram as we go. First of all, she has 2 containers. She has a regular cone and a waffle cone. Now for the flavors, she has 3 options, so we need to make 3 branches off each type of cone. Remember, with your drawing, you can make an abbreviation. You might put an R for the regular cone and a W for the waffle cone. And you can use letters for the types of ice cream as well. Since we have our 3 branches, let's not forget our types of ice cream: chocolate, strawberry, and cotton candy. We also have the choice of chocolate, strawberry, and cotton candy on our waffle cone. Finally, each dessert has 3 options for toppings. We've got to add our 3 branches out for each of the 3 toppings: chocolate crumbles, sprinkles, and the candy shell. We're going to apply the chocolate crumbles, sprinkles, and candy shell to each of our options. When we've completed our tree diagram, we can use it to find our combination. For example, I could have a waffle cone with strawberry ice cream and a candy shell. Or I might have a regular cone with cotton candy ice cream and sprinkles. We can find out how many total combinations we have by counting the bottom branches. How many total combinations do we have? Yep, we have 18 combinations. We can also find the number of combinations with a shortcut. If we take the total number of containers, 2, the total flavors of ice cream, 3, and the number of toppings, 3, and multiply them together, we end up with 18. 2 times 3 is 6. 6 times 3 is 18. Go ahead now and see if you can figure this out. You're going to make a sandwich. How many sandwich combinations can be made if you can choose only one of each of the following? We have 3 types of bread, 4 types of meat, and 3 types of cheese. Make a tree diagram and then tell me how many different combinations can be made. All right, if you made your tree diagram, you should have started with each of the 3 types of bread, wheat, rye, and sourdough. Branching off from that, you would have each of your 4 types of meat, salami, turkey, roast beef, and ham. And from there, branching off from your 3 types of cheese, Swiss, cheddar, and provolone. If you did the math correctly, you should have come up with 36 combinations. Now let's see how many pizza combinations there will be if you can choose from one of each of the following. In this instant, you don't have to make the tree diagram. If you don't want to, you can go ahead and use this shortcut method to figure out how many combinations there will be. All right, if you've made your tree diagram, this is what you would have come up with. You would have your 3 types of crust and 2 types of sauce and your 10 ingredients. So using the shortcut method, we could say 3 times 2 times 10, and we should end up with 60 combinations. Everyone has done such an excellent job today. Thank you for following along and participating. Remember, you can listen to this recording as many times as you need to. And now go have some ice cream. Have a great day.